All right, welcome back to some more math practice. This is the first time that we will be combining the two skills that we have been working up to this point. The skills required for this session are to be able to solve these type of equations, the type that we have seen on episodes 2 and 5 of this series, and also to be able to sketch the type of graphs that we have seen on episodes 3 and 4 of this series. Here's some examples to test yourself and see if you're ready. If you feel like you are a little confused, feel free to go back and refer to those videos. So if you need more time, pause it and check later. Let's check now. All right, so solving these type of equations we've done before, and we see it as something squared minus 36. Hopefully you're thinking that way. We're going to add 36 to both sides. We get something squared equals 36. The something is x plus 8. And we know that something squared is the way we think about this, equals 36. What two numbers can be squared to get a 36? They're positive and negative 6. That's our something. Something is x plus 8. And last step is to subtract that. All right, subtract 8 on both sides. We get a negative 8 plus or minus 6. So we get that x is equal to, now I am going to start to check those answers. X is either a negative 14. We got that by negative 8 minus 6. And then negative 8 plus 6 will give us a negative 2. Those are the two solutions. Hopefully you're really comfortable with that. And another variation of that, when it's 64 minus something squared, all right? Remember that equal to 0. It's very nice. We can add the something squared to both sides. It's going to give us 64 equal to something squared. The something is x plus 3. And something squared equals 64. The two numbers squared to get a 64, or if you're starting to think square root, plus or minus 8, equal to the something, which is x plus 3. And last step would be x equals, we're going to undo the plus 3 by subtracting it on both sides. Negative 3 plus or minus 8. And that can be x equals negative 3 minus 8 is negative 11. And the other answer is x equals negative 3 plus 8, which should be 5. Checking my work there. Hopefully that's correct. Yeah. All right, so this shouldn't take us this long to do this at this point and be able to get those numbers, all right? Check your work if you've been doing that all along. Okay, next, like I said, the point is not just being able to sketch these, but do them quickly. I always start remember, a reminder to myself is the most important point on these type of graphs is the vertex. So I would like to start with that. Where's the vertex located? When the something squared is equal to 0. What makes the something squared equal to 0? When x is 0. So always start for me with the x value. And then when that is equal to 0, we get 16 minus 0, which gives us 0, 16. And the last thing is check curvature. The negative belongs to the something squared, therefore it is curving down. Remember that we spent a lot of time doing graphs like that. And there we go. There should be nice curvature to that. I'm going to get more detail in my next few graphs. And again, they get a little more advanced. 25 minus something squared. When does the something equal 0? When x plus 7 equals 0. That is at negative 7. Negative 7 plus 7 equals 0. And that gives us the vertex, the y value as well. X value and the y value is 25, because 25 minus 0 is 25. And remember that the negative, it belongs to the something squared, which implies that this graph curves downwards. And at some point I've been saying I don't know how to label, or I do know how to label, but we weren't worrying about the x and y intercepts up to this point. This is the part where the practice where we will be doing that. Okay. Last one is, where's the line of symmetry whenever the something squared is equal to 0? That is, in this case, at negative 5. X equals negative 5. When that happens, we get a 0 minus 9, meaning the y value is negative 9. Negative 5, negative 9, the coordinates of the vertex, and this is curving upwards. And again, for this number 2, I won't, or number 1, yeah, number 2, I won't be labeling the x-intercepts. But what I mean by that is this point where it crosses the x-axis, this other one, and this one. They may be incorrect, but that's our goal for this lesson. I'm going to show and remind you how to do that if you haven't done it with linear equations. If you have done it with linear equations, it's still worth the time to take and revisit that idea. Maybe if you forgot why, okay? Especially if you forgot why. So number 3, let's remind ourselves something about x and y intercepts, all right? Here's a x and y plane with some accurately labeled tick marks, so 4x4 on in each direction. And I'm gonna highlight a point, and let's think out loud, or I'll say it out loud, and you check with me what x value I'm highlighting. Okay, so what x value is this? This is x equals 1. What x value is this one? 3. And this one, -4. And here, -1. And here, okay, does those x values change, or were they the same number? Those were changing, right? Obviously. Okay, let's try some more values here along that x-axis. And now let's talk about their y value. When I highlight it, think about what the y value is. For example, here, what's the y value here? It is 0. What's the y value here? 0. What's the y value here? And 0. What's the y value here? 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 And here, and here, and here, and here. All of those are 0. So the question is, what is true about all the points on the x-axis? They're going to be called x-intercepts. Is that their y value is 0? Because the x value was changing, but the y value was not. Y value is 0, and that's true for all x-intercepts, for all types of graph. It applies to linear equations. It applies to parabolas, like the ones we're going to explore today. That's a very key idea. We're going to use it a lot in the next in the next 6 problems, actually. Okay, and let's do the same kind of thinking about the y-intercepts, or the y-axis. So now let's focus on the y-axis, which is where lines will intersect and they're therefore called y-intercept. What's the y value here? It's a 1, and here, -4, and here, -3, and here, -1, and here, 3, and 4. Are the y values changing or staying the same here? They're changing. Y values are always changing here. But what about their x value? What's the x value here? It's obviously 0. What's the x value here? 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 0. And here, and here, and here, 0. And here, 0. And here, 0. And here. All of those places, any point on the y-axis has an x value of 0. Okay? I think that's very easy to remember and convenient. Value is 0. That's very key. Now, the way I'm going to abbreviate that letter, I'm going to say x equals 0. I'm going to put in parentheses and say x equals 0. And for y-intercepts, x equals 0. And for x-intercepts, I'm going to abbreviate it like this, y equals 0. Hopefully, we're okay with that. And let's start applying that idea. Okay? So look, here's a type of equation that we've done before in terms of sketching it. And we've done it very quickly, but we haven't labeled any x or y-intercepts. So let's do that right now. Not only are we going to label coordinates of the vertex, which we should be very comfortable with now, like I said, x-intercepts and y-intercepts, applying the idea from right here by saying y equals 0 and x equals 0. And equation for line of symmetry is something we've done before, and we'll just make a cleaner sketch than we've done in the past. All right, so again, I always think of the line of symmetry for the vertex. It's when the something squared is equal to 0. What value of x makes the something squared? 0 is when x is 0. That's the line of symmetry. X equals 0. Matter of fact, I can write here on the side. That's letter D. We already got this part, like equation for line of symmetry. Done. Now we need the y value to finish letter A. And when x is 0, we get 0 minus 9. I think we did this one earlier. 0, -9. And notice that it's crossing the y-axis, therefore the x value is 0. It connects to what we did before. So not only did we find the vertex, we found the y-intercept, okay? We've located that, and we know there's symmetry about that. Whoops. I always struggle with these myself, so let's try that again. It should be something like that. Excellent. I'm more pleased with that one. And notice how our vertex happens to also be our y-intercept. So that's also something I'm going to write here. Letter C is y-intercept. It is 0, -9. Perfect. And the only thing that remains for us to do is to label this point here and this point there. Those are called the x-intercepts. All right, so I'm going to do some side work here on the side. I'm going to say x-intercepts. What do we know about x-intercepts? That's why we wrote that statement above. We know that for all x-intercepts, their y value is 0. That's what we wrote up here. All x-intercepts have a y value of 0. So that's key, because we have an equation that starts with y equals, look at that, y equals something squared minus 9. That means we can plug this in directly to that equation. I will do that here. All right, so 0 equals x squared minus 9, or something squared minus 9. And we know how to solve this type of equation. We have to undo this minus 9 first. We're going to get 9, adding it to both sides. 0 plus 9 is 9. And then on the right side, we left with x squared. Therefore, we know x equals plus or minus 3. And be careful, that doesn't mean the x-intercepts are -3. Don't think this. I'm going to erase it in a little bit, but don't think this. This is absolutely wrong, right? It doesn't mean that. What it actually means is that -3 is one of the x values for the intercept. What was the y value? Look, we highlighted it up here. The y value for both of those points is 0. So it's -3, 0 and 3, 0. Obviously, the 3 has to be on the right side, the +3, and the -3 has to be on the left side. So use that as your common sense to figure out which one is which. But remember, avoid this idea of saying, oh, it must be 3, -3. That's incorrect. 3, -3 would be some point up here, which would not even be on the actual parabola itself. And there it is. There's a graph with 3 points that are labeled. All right. I'm going to skip showing the work for this one. If you plug in x equals 0, you still get a -9. I hope that you can visualize that. But if you ever realize that you already solved for the vertex, no need to show the algebra anymore. This one we didn't know, so the algebra was required. All right, let's explore more advanced ones, however. All right, that's like the more basic one. Some that might require us to do more work or not. Let's see. 16 minus x something squared. What makes the something squared equal 0? Remember that we know how to sketch this very quickly. And that is when x equals 0. And remember, that was the line of symmetry, or letter D. When that is 0, we get a y value of 16. So we get a y-intercept, hopefully you can see that, of 0, 16, which turns out to also be the vertex. And because it's negative something squared, this is a parabola that curves downwards. That didn't work out. I tried. There we go. We can use this type of drawing technique as well, where you do one half first and then the other. That could work. And notice how that's not only a vertex, this is the vertex. It is also the y-intercept, but just be careful. That's not always the case, all right? This is just a special case of that. So we've done letter A, and this one is letter C, part of letter C, the y-intercept. Because, oh yeah, B is separate. So I didn't label this one as letter B, but there we go. All right, and then notice how the last thing we need to do is figure out what this point is and what that point is. And maybe at this point, some of you can figure it out in your head just without doing any work. But I'm going to show the work somewhere here on the side, all right? What do we know about all x-intercepts? Is that their y value is 0. That's a statement that I'm always going to write to remind myself what to do. I think this one's letter B. What to do when trying to solve for x-intercepts. And that all that means is replace wherever the original equation, there was a y, we're just going to replace that with a 0, right? So if you need to write it down, then say y equals 16 minus x squared, and then substitute that with a 0. If you need to see a little more steps, I won't always be doing that. I'll just do it one time so you can see what it would look like if you did choose to do that yourself. And hopefully you're okay with me solving this pretty quickly now. Plus or minus 4. Again, the reminder is the x-intercept is not 4, -4. There are two x-intercepts. One of them is 4, what? 4, y equals 0. There we go. Always remember that. And the other one is -4, what's the y value? 0. And there it is. This is a parabola in which we have labeled 3 points. Vertex, y, but the vertex happened to be the y-intercept, and we labeled it 2 x-intercepts. All right, that's pretty nice. Okay, the next type of graph, we also have some experience with y equals something squared. Y equals something squared. What makes the something equal to 0? And again, if you would like to prefer to think as plus 0, you can, but you don't have to write that plus 0. We will get that lowest y value of 0 when x is 8. And not drawn to scale. I'm just estimating what this might look like. When x is 8, we have a y value of 0. Is it a lowest or a highest point? Because it's positive something squared, it's going to be a lowest point. And remember, the graph is going to have curvature like this and symmetry. And hopefully you notice something. Does the graph intersect the y-axis? Yes, it does right here, right? It does right there. Cool. We have to solve for that because now it's not the vertex. Remember I said that was just a special case before. Now the y-intercept is not the vertex. This is another type of special case that won't always be happening. But where does the parabola intersect the x-axis? Well, right there at one point. Only at one point right there. You see that? It only does it at one point. So we know the x-intercept is only that one point. And what do we know that point is? A comma 0. And in this case, it's also the vertex. So a comma 0 is the vertex and the x-intercept for this type of parabola. Again, it's a special case. This won't always occur as you have seen before. But that means we don't have to do the algebra for that. We just need to solve for the y-intercept now. I'm going to do it here on the side. What do we know about all y-intercepts? Is that their x value is 0. So again, I'm going to take the original equation given to me and now substitute x equals 0. So y equals x minus 8 is the something, and then square that. So we're going to say y equals 0 minus 8. So therefore, y equals negative 8 squared. So y equals 64. All right. And what was the x value there? It was a 0. It is labeled right here. That's why I always get in the habit of writing that. It is 0 comma 64. All right. So the y-intercept is 0 comma 64. X-intercept is 8 comma 0. And that's all that we could probably label up to this point. If you know a little bit about symmetry, you may be able to label a point right here very easily. But that's not the main goal for this lesson. That will come in the next one. But the idea right now is being comfortable solving for x and y-intercepts. I invite you to do the algebra and check that it is indeed just one x-intercept. All right. The picture shows that. The algebra should also verify it. Okay, and try to go a little bit faster with these, especially because I do want to spend more time on more advanced ones, okay? So this was very similar to the previous one. It's just with a vertical reflection. It's reflected downwards. What makes this something equal to 0? It is when x is negative 7. When x is negative 7, there's our line of symmetry labeled already. We have our lowest point or highest point. So we have negative 7 comma 0. And that, as we know from the previous problem, will be a x-intercept. And y-intercept intersects in the negative direction. So that should make sense. The y-intercept, if we need to do a little bit of work, happens when x equal to 0. Don't forget that. And therefore, we're going to say y equals negative 0 plus 7 squared. And then we know that that's just negative. But notice how the negative's now on the outside of the parentheses. Before it was on the inside. So then that gives us a negative 49. And therefore, we know that 0, negative 49. And the picture confirms that. All right. If you get an answer that's positive, but your picture says it should be negative, you should double check what you're doing. That's the nice thing about graphing these and using algebra to confirm. All right. So there it is. This very quickly sketch and solve for x-intercepts and y-intercepts. And if you wanted to label that point, it's probably not that hard, but I'll show you in the next practice. All right. The next 3 problems are where I want to spend more time. And these are the most commonly seen, actually. So I just didn't want to skip the basics. But let's spend more time on these. We actually are going to do a lot more work with these. So letter A, let's start with the vertex. And I'd like to always find the line of symmetry. That is when x is -4 in this case. X is -4 is our line of symmetry, and that's letter D. Doesn't have to be done in the same order that is being asked, okay? And when that is equal to 0, our lowest y value is -36. Whoops, it should be -4, comma, -36. All right. I'm gonna try something here actually. Okay, never mind. Let's just move on. And there it is. This letter A actually, the vertex. The next thing that we asked ourselves is let's find the x and y intercepts by using algebra. So we're gonna do that here. What do we know about x-intercepts? Before I even draw my parabola, now I'm gonna wait and figure out that I have the correct x-intercepts before I make the sketch. X-intercepts occur when x equals, I'm sorry, let's redo that. When what? When y equals 0. It's a good habit to write down, and I will just take this original equation, find the y located, it is right there, and replace that with the 0. And let's do some algebra. 0 equals something squared minus 36. We've been working on these type of equations for a long time, and it was all for this. And how do we undo the minus 36? Let's add it to both sides. So we get 36 equals something squared. What's the something still? X plus 4. And then we know that two numbers were squared to get a 36. Those were positive, -6. The something is x plus 4. What's our last step to undo? Adding that 4 by subtracting it on both sides. -4 plus or minus 6 is equal to x. And I will write the 2 points here and then plot them on the graph, all right? But remember that their y value for both of them is 0. Don't forget that. That's the main idea here. So there's 2. We have -4 minus 6, which is -10. So -10 comma 0, and we have -4 plus 6, which is 2. And remember that we know that their y value is 0 for both of them. So now we can plot those 2 points. If this is x equals -4, then 2 comma 0 must be somewhere over here. 2 comma 0 must be somewhere right there. And remember the idea of symmetry. Whatever distance we have from this point to this line should be the same from this point to the other x-intercept. So somewhere right there. Oh, maybe not right there. I think it's a little further out. I think it's somewhere right there. All right. So what I'm aiming for is, so you can visualize it, I'm trying to visualize that this distance right here is the same as this distance right here. That's what I'm trying to visualize when I do that, because remember, these are symmetric graphs. And then I know that parabola goes through the x-axis, reaches its lowest point, and then it does the same type of behavior on the right side. Reaches the other x-axis and goes up forever now. But that's the main idea. This distance is equivalent to this distance on the left. And that looks pretty nice in my opinion. We have 2 comma 0, and the other one we can label now very accurately as -10 comma 0. Look, we're starting to put the pieces of the puzzle together very nicely. We have labeled 1, 2, 3, but we're missing one more point where the parabola intersects the y-axis. Where is that? Right there. And remember that we also know how to do the appropriate algebra to do that. That is letter C we're going to do here on the left side. For the y-intercept, what do we know about all the y-intercepts? That their x value is 0. That's right. So therefore, we can use our original equation as before and substitute this x with the 0. So let's do that here on the left side. Y equals 0 plus 4 squared minus 36. I'm going to let you do that in your head and just write the answer down, okay? That should be a -20. Again, if you wonder how I did that, it was 16. 4 squared is 16 minus 36. That's just -20. So therefore, this x y-intercept, the x value is a 0, and the y value is a -20. Okay. And look at that, we have a total of 1, 2, 3, 4 points very accurately labeled. And in the next video, we will easily figure out how to label this guy right here. That's not the point for this one, but man, we're doing a lot of complex stuff right here. And that, not that it's difficult, but there's a lot going on. And you should be proud of yourself if you understand everything up to this point. This is advanced stuff going on right here, in my opinion. All right, I encourage you to try this one by yourself if you would like. And if you didn't want to, let's check it together now. All right, so let's do the easiest part first. For me, is finding the line of symmetry, which is when x is equal to 3. When x is equal to 3, we have our either highest or lowest point. In this case, it's positive 3. There we go. And because it's negative something squared, now I know it's going to be a lowest point, and I mean a highest point, and that highest point, y value is 49. So the vertex is located at 3, 49. 3, 49 is, this is letter A, done. This one is letter D, done. Now we need x and y intercepts. So again, I'm gonna hold off on making my parabola in case I missed the incorrect, or make the incorrect graph. I don't have to fix it. So I would like to do x-intercepts first. Letter B. What do we know about all the x-intercepts? Is that their y value is 0. And now let's do some substitution. Here's y. I'm going to substitute that with the 0 down here. So 0 is equal to 49 minus something squared. Oh, my favorite type of equation, because we have a 0 on one side and minus something squared on the other. So therefore, I'm going to add that to both sides. That's why I've been showing those type of examples a lot. Make your life a little bit easier here. And therefore, the something is still x minus 3. What two things were squared to get a 49? Those were the something was either a positive or a negative 7. The something is x minus 3. And therefore, we know x equals 3 plus or minus 7. Hopefully, you're okay with those steps. And therefore, we know that the 2 points are either going to be, put them here on the side, they're either going to be a 3 plus 7, which is 10, 0. Don't forget the y value is always 0 for these. And we have 3 minus 7, which is negative 4, comma. There we go. 2 points, as we should expect, since our parabola is going to be curving downwards, we should expect it to pass through those points. Now let's make sure we do them correctly. If this is x equals 3, then 10, 0 is 7 units to the right. Let's say it's way over here. Let's say that this is 10, 0. Therefore, we know that whatever distance from here to here, maybe I can draw it in blue again like last time, but so we can think about it. No, let's just start thinking about it. Therefore, we get used to doing that all the time, and just visualize that whatever distance we have from here to here, it better be the same distance from here to wherever that point is, which should be a negative 4. That should be somewhere right here. And again, this is not the best scale, but the points are very accurate, which is the most important thing. And hopefully you're starting to visualize a very nice symmetric parabola. All right, I'll start connecting those dots. I think I'm gonna redo that. Start like this. Going up. Oh, missed it. Going up, reaching its highest point, and then symmetrically going back down. It's a lot easier for me to do this on paper, but you guys get the idea, I hope. Hopefully you visualize that nice symmetry. I'm gonna try to clean it up. There we go. It's not the best thing, but there we go. I think it made it look a little better. All right. And is there anything else that we're missing? Oh, we're missing a very key point right there. Where does it intersect the y-axis. Well, what do we know about that? It's going to be 0 comma something, right? That's something we are already going to get in our brain. So therefore, we can do this side work here. We know that for all y-intercepts, their x value is 0. So therefore, we know that y equals 49 minus negative 3 squared, all right? Which should be negative 40. I'm saying positive 40, my fault. And that should make sense here with the graph. Oh, that's not cube. That should be a square. I just did the work in my head. Hopefully you can confirm that. Trying to make sure that we have one last problem. All right. Again, I always encourage you, if you want to pause and try yourself. I know this has been pretty long, but this is every type of scenario that you could possibly see. Vertex is when x is negative 6. When x is a negative 6, we get a positive 4. And you're going to realize that this is curving upwards. So hopefully, you know, they start thinking about the x-intercepts. What does this picture tell you about the x-intercepts? Look at the picture. What does that tell you? That there has no x-intercepts, and we can show that using algebra, right? So look, that's the main thing that I wanted to point out about this one. X-intercept is when y equals 0. And that is the equation 0 equals something squared plus 4. Let's see how the algebra would tell us that there are no x-intercepts. How do we undo the plus 4? By subtracting 4. So negative 4 equals something squared. Now let's think about that. Can we square something and get a negative value? The answer is no. Therefore, no real solution in this case means no real x-intercepts. All right, that's the way I'm going to say that. No real x-intercepts. And the y-intercept, very easy to find. What do we know about the y-intercept? When x equals 0. When x equals 0, we're going to have y equals 0 plus 6 squared plus 4. Or 36 plus 4, which is 40. So 0, 40. We could still solve for that one. But I wanted to show this particular example. This is the last one because there are scenarios where there are no x-intercepts, and the algebra will confirm that. All right, this is it for our practice for today. This just wanted to tell you that we've done a lot, put a lot of pieces together. If you stuck around for the whole thing, then you're probably excelling at this point, or even if you don't feel that way, you're gaining a lot of experience, and that's the point of this. Okay.